So now let's do a matched pair example with a hypothesis test. So using the data we had up above when we did our confidence interval up here, we want to test the hypothesis that mean fuel economy for type 1 gasoline is greater than that for type 2 gasoline against the null hypothesis that the two formulations of gasoline yield the same mean fuel economy. And we want to test at the 5% level of significance using the critical value approach. Okay, so let's go through our critical value approach. Let's remember first we need to state our null hypothesis. Now, when dealing with these matched paired examples, it's going to look like the mean sub D. And let's see if I've got what I mean by that, because I'm not going to type that in here very easily. Yeah, like this right here. So it's going to look like, the first part's going to look like mu sub D, just like that. All right. And of course, all our nulls are always equal to something. Now, I'm just going to say mu, and let's see if I can't put little sub D on there. It's like that. All right. Is equal to. Now, we're testing the hypothesis that type 1 gasoline has greater fuel economy than type 2. So our null hypothesis is going to be that there is no difference between the two gasolines. All right. Notice that the null hypothesis that the two formulations of gasoline yield the same mean fuel economy. So if they both had the same fuel economy when we subtracted them, our result here would be 0. And we're going to see that most of these, that's the case, that mu sub D will be 0. And then we need to look at what our alternate is. Now, since we are looking at whether or not the type 1 gasoline is greater than the type 2 gasoline, if we were to subtract the type 1 minus the type 2, we'd get a number larger than 0. So we're going to say mu sub D, that difference should be a number larger than 0. Okay, now alpha, we saw is 0.5 up here, 0.05, I'm sorry. And then since this is a right-tailed test, let's go ahead, subtract that from 1, and we want to look up 0.95. And again, our degrees of freedom are equal to the number of pairs minus 1. And up here we had 9 distinct pairs. So 9 minus 1. So we're going to look up 0.95 degrees of freedom 8. So equal T dot inverse 0.95 degrees of freedom of 8 gives us a critical value of 1.860 if we round to 3 decimal places. All right, so our critical value is 1.860. Now remember, since this is a right-tailed test, that means anything to the right of 1.86 when we do our test statistic means that it will be in the rejection region. So let's go ahead and do our test statistic. We have this new test statistic. All right, let's notice what we've got. T equals D bar. Now you may remember in the prior example, we took these differences and we took this whole column and we found the mean of this column, and that was D bar. And our mean was 0.14 up here for D bar. So let's stick that in there. So we're going to have 0.14. The D sub 0 is whatever we've got right there. And most of the time it's going to be 0. On the bottom, we want the standard deviation that we got for the difference. Now, going back up here to the previous example, we had also taken that column, and when we put it into Excel, we got the standard deviation. And that standard deviation is sitting right here in my calculation from last time, 0.166667. So let's fill in 0.167, and we want to divide by the square root of the sample size. And remember, it's the number of pairs, in this case 9 pairs, that is our sample size. So that's going to give us 0.14 divided by 0.055555. We'll go round there at the end. And let's do our final calculation of dividing those up. And that gives me 2.520 if I round to 3 decimal places. Now, there's our test statistic. If we look at 2.520, it is certainly to the right of 1.860, so it's in the rejection region, which means we reject the null hypothesis. Okay, so let's state our conclusion. There is sufficient evidence alpha equal 0.05 to reject the null hypothesis. It appears that the fuel type 1 is delivering better gas mileage than fuel type 2. And there we have it.